So elimination method is a way to solve, okay, so we're going to solve the system by combining the two equations in a way that one variable zero pairs out. In other words, it's eliminated. So first, if the equations are not lined up, you want to line them up. Even the equal sign, all right? So honestly, elimination method is what I would advise you use if your two equations are already both in standard form. It's perfect time to use elimination. So, and then you can add or subtract the equations to eliminate the variable that has a common coefficient. So in other words, if there's a 2x and another 2x, we can subtract them. We can subtract them to get rid of them. If there's a 2x and a negative 2x, we would add them to eliminate the common variable. So common coefficient, in other words, the same number of that variable. And then after we've done that, then we only have one variable in the equation, so we can solve for that one remaining variable. And then like what we did with substitution, if you've also done substitution, is then we can substitute your answer into either original equation and solve for the other variable. So I'm going to skip around and do a few examples here so that you have a couple of examples. So the first example I'm going to do is number 2. I skipped number 1 because number 1 I would really prefer to do a substitution method, and so I'm going to go to number 2. So with number 2, I see that there is an x, just a single 1x in the top and the bottom equation. So the x has the common coefficient. But they are the same signs, so to get rid of them, I need them to be opposite signs. So basically I need to subtract the two equations. So when I subtract, then that's going to change every sign, and I'm going to make it the second equation, but it could be the first one, but it changes every sign in that equation. Then I can proceed like it's addition. So x and negative x, 0 pair out. That adds up to 0 x's. They are eliminated. 4y and 1y, we have 5y now. 13 and negative 3, positive 10. We can divide by 5. We get y is equal to 2. And this is a system, so we need x and y. So now I'm going to replace the y in one of the original equations. I'm just going to jump into that top one. So I replaced the y with the 2. X plus 4 times 2 is equal to 13. 4 times 2 is 8. So x plus 8 is 13. We can subtract the 8, and x then is 5. So our ordered pair would be 5, 2. If I want to be sure that that's right, I take 5 and 2, put them into the original second equation before I change the signs. So before I change the signs, which would look like that, right? And I have 5 minus 2 is equal to 3. Looks like truth to me, so it works. All right? So when the common coefficient has the same sign, you need to choose one of the lines and change all the signs. Because if I add together 3x and 3x, that doesn't eliminate. So what we're doing when we do that is basically that it's subtraction, but because of the signs, it's going to be easier to change the signs and then treat it like addition instead of thinking of like -10 minus -9. Something should eliminate then. If nothing eliminates, then we may have missed that we needed to do another step first. You cannot solve the equation while it still has two variables. So finding the first of the two variables is going to be pretty quick, because after I eliminate, all I have to do is divide. And then finding the second, you're going to replace the y with 1 to find the x. Look down, I didn't finish that problem, I am aware. I'm going to look down at number 4, because number 4, I want to show you that you can also eliminate the y's. It doesn't have to be the x's that get eliminated. So in this case, my common coefficient is that both of these are 2y. But they're also both plus 2y. So I'm going to need to make some sign changes, either on the top or the bottom, so that they will actually eliminate when I put them together. So if I choose the bottom line, if I subtract this whole line, this becomes plus, this becomes minus, this becomes minus. Now I can put them together, 4x and 2x, 6x, the y's are eliminated now, 6 and -18 is -12, divide by 6, and we have x is -2. So, caution, now we have x is -2. When you plug it in to find the value for the other variable, we just did it, the first few we found y first. This time we found x first. So then it's important that it substitute in for the x. So then we would do 4 times -2 plus 2y is equal to 6. So -8 plus 2y is 6. Add 8. Divide by 2, and we get y is 7. And then we can check that by replacing both variables into the other equation that we didn't use yet to plug in. So -2 times -2 plus 2 times 7, we are hoping that that's going to equal 18. Two negatives multiplied to be a positive. So 4 plus 14, 4 plus 14, check, check, that is 18. So I like my answer. I should write my final answer as an ordered pair. So even though I erased my sign changes on number 4 when I went back, so far 2, 3, and 4 we had to change the signs because the common coefficient had the same sign. I'm going to show you on the other side of the page an example where you don't need to change the signs first. Okay, so 5, 6, 7 on this page. All of these I would not need to change signs before I put them together. I have a common coefficient. Both x's have 4's. One is +4, one is -4. So I can simply add my two equations together as they currently sit and my x's will be eliminated. That gives me 16y is equal to 16. So if they're opposite, that's really sweet, because then I don't even have to change signs. When I divide by 16, we get y is 1, and then the process is very similar. Again, paying attention, if it says y, be sure you're replacing the y with that number. If it says x, replace the x. And be careful that your x's and y's, sometimes x and then y, and we get kind of, and ooh, gosh, is that my x or is that my y? So be careful that you can read your own handwriting. I understand that challenge. And then you've got your two-step equation. You'll subtract and divide, of course. And once again, you can try the check. 4 times negative 1 would be 4, and 7 times 1 is 7, and 4 plus 7 is indeed 11. So it works. So you can do the check just by talking it through like I just did, or typing it in your calculator to make sure it works. So when you see something is opposite, they would zero pair out when I add them together. Don't multiply, don't change signs, just start adding them together, the two equations together. Right, so there is a homework page after that. So if you are, depending I guess on when you have my class, and so on this homework page, we did only the front side of the page. Okay, partly because on the back side of the page, we started getting into some things that might be better suited to do substitution, or they're just not as similar to the elimination problems that I will give you. All right, they would take more, you would have to manipulate things, move things around before you could try to eliminate. So again, that is elimination when there's already a common coefficient. I'll be making a second video for when there is not a common coefficient for elimination.